Hello my dear students, how are you all? Welcome to Diksha Karnataka YouTube channel. I hope all of you are doing good. Today is day 48 of our series 6 out of 16 KCET Mathematics in 100 days. Okay, so a very pleasant chapter going on right now. Simple chapter, simple concepts, vectors, algebra. Okay, so in this session we'll talk about addition of two vectors, okay, addition of more than two vectors, not only just two vectors, and the properties of additions of vector, okay, as we have seen them in our algebra as well. When we are adding scalar quantities, same properties, similar properties we'll learn, and we'll see how it works for vectors. Okay, so we have done one session in vectors. In that we talked about simple definitions of the vectors and some types of vectors as well, and solve questions on it as we do every time. Today we'll again solve 12 more questions, 12 questions on this particular topic. So I hope you're prepared. If you want to take a break, please take a break, okay, but if you're starting this session right now, please watch all entire session at once, solve all the questions at once. The questions will be easier today, easier to moderate. Okay, some questions are very good, but even though they'll take not that much of time to solve it. Okay, so let's quickly wrap up this session. For that, take out the pen and paper and solve all the questions with me. Let's start the first session. First slide coming up is on addition of vector. Okay, how do we add vectors? So bacha, here we have two rules, as you already know. If you know, first rule is using triangle rule of addition. Second one is using parallelogram rule of addition. So first one, so basically to prove or to see the addition in vectors, we draw a triangle, and from there we say, why we draw a triangle? So because we have to use what? Directed line segments, right? We have to use what? Directed line segments. So there has to be a direction given. That's why we have to use a figure. So triangle, right? So let's look at the triangle law of addition. Okay, so what are you going to do? First, let's say I'm going to take a point of origin, because every vector is measured from the point of origin. Let's say this is my point O. I start from here and write this as, let's say, my first vector at this point with A, and I name this vector OA to be vector A. All right, and second one has to be joined what? Head to tail. You know this, right? This is a tail on initial point, this is a terminal point. Second vector has to be drawn from which end? This end only. So please have a look. This is my second vector, which can be written as vector B. Okay, vector B for this point B. So if the vectors are written like this, A and B, then the sum of the two vectors A and B will be given by what, bacha? Will be given by the vector joining the initial and the final point. Think about it, think logically. Let's say you are standing at this position. Okay, you are trying to move from point O to point B, but you have to take this path because this is the only road which is given to you. Like this you'll go, and then this you'll go. Then this is your initial point O, and this is your final point B, right? What a physical quantity that you use right now? You use distance covered like this, right, on the path OAB. Whereas the distance OB is what? Is actually the displacement. This is a vector quantity because it's the direct distance between the point O and B, or also called as shortest distance between the point O and B, right? So that's why the direction has been included over here. So if I have to say, what's this thing? So isn't this going to be the vector addition of the vector, the distance over here and this over here? So I can call this to be what? The vector addition of what? A plus B can be written as the resultant R. The resultant vector R will be given by A to B. So if these two are the vectors like this, this is the displacement vector given in the terms of OB, written as vector A plus vector B. Okay, this is the addition of triangle law. Please let's read the statement. If 3 points OAB are chosen such that OAB represents vector A and vector B respectively, then OB is defined as the sum or the resultant of the two vectors given in this form. Okay, simple. It looks simple, it is simple. Okay, we'll see the application of this. We will use this law to add vectors to get the next result on the vector, which is on parallelogram law of addition. So parallelogram law of addition is actually based upon the triangle law of addition only. Okay, let's have a look. Now second condition, whenever we have two vectors, whenever we have what? Two vectors like this, vector A, this is my vector A, please see, this is my vector A. Okay, written over here is vector A, and this is my vector B. Please check it out, vector B. So if my vector A and vector B is written like this, okay, which is nothing but the two adjacent sides of a parallelogram. This is the given condition. What is the given condition? If I have two vectors represented like this, OA and DA and DB, what is it? DA and DB, okay, which represents what? The two adjacent sides of the parallelogram, then directly the rule states that the line, the diagonal of the parallelogram will be the resultant. Okay, so I'll just highlight this also. This will be the resultant. How? We'll see the derivation right now. We'll see how it comes, but this is your result. Okay, what is it? Vector A plus B. Okay, A plus B. All right, now, so what was it? The statement I'll repeat once again. If there is two vector A and B, which are what? The sides of the adjacent side of a parallelogram, then the resultant of the two vector will be the diagonal of the parallelogram. Let's see how. Can I translate this vector in same way over here, right? Because they are equal, no? Opposite sides are equal, right? In the case of parallelogram. So basically, I can write DB. This is DB, right? One second, bacha. This is DB. So I can write DB as AC. As what? AC. Have a look. So my B can be translated, can be transposed to this point. Okay. Now what can you apply? Can you not apply here? Please check. Vector A plus vector B. What is it, bacha? Have a look. Vector A plus vector B. Triangle law of addition. So A plus will be what? This resultant. Isn't this actually represents the resultant of these two vectors? So first I gave you the statement. Now I'm trying to prove you the statement. So vector A plus vector B will give me this thing, which is nothing but the resultant. Yes. Now, so basically the conclusion that we are getting over here is that this diagonal is giving us the resultant, and that's what the statement says. What's the statement? If you want, I can write it here. Okay, yeah, it's given here. If two vectors A and B are represented in magnitude and direction by two adjacent sides of a parallelogram, then the sum C is represented by what, bacha? Please check. The diagonal of the parallelogram. The diagonal of the parallelogram, which is co-initial with the given vector. Co-initial vector, right? A plus B is also a vector. Vector A and vector B are all co-initial at point D. Co-initial at point D. Please have a look. Co-initial at a point D. Okay, chaliye. This is clear. I proved it. So to prove the statement of this, I used what? I used the triangle law of addition. I transposed this vector B to this point parallelly. They are equal because of the opposite sides of the parallelogram. Okay, they are parallel also. We know that, right? Then I can add this using triangle law of addition and I get this resultant to be A plus B. That's it. Okay. So basically, if I have to summarize this, I can write in the triangle form also. If I look at the triangle DAC, please check. Triangle DAC, vector DA plus what is it? AC. AC is equals to what? Is equals to DC. And now we know that AC is also equal to DB. So I can write DA as it is. DA as it is. And what is AC? So DB. Opposite sides of parallelogram equals to what? DC. And this is the statement of parallelogram law of addition. See? Please check. A plus B equals to C. A and B are the sides, right? DA and DB are what? DA and DB are adjacent side. And what is DC? DA and DB, please check here. What is this? Here, if I mention again, okay, where is written here? What is this? DA and DB. Okay, and what is this diagonal over here? DC. Alright, so I hope it is clear now. Please have a look. DA and DB are my adjacent sides and diagonal is DC. This concludes your statement for what you call statement and proof for your parallelogram law of addition. Okay, same thing I think is written over here also. Have a look. BD equals to AC, correct? And then what we are getting finally, DA plus DB equals to DC. Right? Shall I move on? Yes. Question number 1. Let's solve it. Vector drawn from the origin O to the point ABC. They're given here for the point A, for the point B, for the point C. Let's draw it. So I'll take this point to be, let's say, origin. From O to A, let's call this to be O to A, point A. O to B, let's call this to be point B. O to B. And I have a point O to C also. let's say like this, O to C. The length they have given here, bacha, the length is given as, this is vector A, this is what, vector B, and this is what, vector 4a minus 3b, 4a minus 3b. Now what are they asking? They are asking something, right? Please have a look. They are asking us to find AC first. So isn't this AC? A to C. So this is the arrow. Please check A to C. Now if you see carefully, vector A, AC and OC is forming the triangle law of addition. Can you see? It's satisfying the equation, no? This plus this is equals to OC. So in this case, if I consider what? If I consider, bacha, triangle OAC. Triangle OAC. Please see carefully. Okay, isn't vector OC a resultant of what? OA plus AC. You can see from here also, A and A will be added, will become OC again. Okay, so OA plus AC equals to OC. Condition, what is the one condition? Terminal point of the first vector with the initial point of the second vector. Please check this point. Terminal point of first vector is what? A, and second vector's terminal point is what? See, this is the terminal point A, and initial point of the second vector is A. They have to be common, right? Terminal point of the first vector has to be same as initial point of the second vector. Are they same? Yes, OA plus AC. So now put the value. What is OC, sir? OC is 4A minus 3B. What is OA, sir? OA is simply A. And what is AC, sir? That's what we have to find it out. Keep AC on that side and bring A on this side. It will become what? 4A minus 3B minus A equals to AC. Right? A is moving on this side, so it becomes negative. What is my result, bacha? Please check. My result will be vector AC is equals to what? 4A minus A. 3A minus 3B. Minus 3B. So what is my result? AC equals to 3 times of A minus B. My first answer. Okay, now moving to the second part. What is the second part, bacha? This is asking for BC. So draw BC again. So how can I write this? Please check again. Initial point, terminal point of OB is B, and initial point of BC is again B. So I can write this as vector OB plus what, bacha? Vector BC is equals to what? Again OC. Correct, na? See, a terminal point over here is same as the initial point, so I can add it like this. Okay, the triangle law of addition will apply to this. What is OB? Simply B. What is BC? I don't know, that's a variable, so BC as it is. What's OC? 4A minus 3B. Yes, 4A minus 3B. Bring B on that side. I'm being patient right now. I want to go slow right now, because it's very important to understand the concept, how the flow is, how the triangle looks like, how the application of triangle law of addition is. Then you can speed up in the problem. So you'll see now. So for now, 4A minus 3B minus B. What is that, bacha? 4A minus 4B. How much is that? Take 4 common. This is my BC. This is your answer now. This is your answer now. AC is this, BC is this. I hope this is clear. Please have a look. Okay, I'll move on to question number 2. All right, just draw the figure, and from there you have to apply what? Triangle law of addition. What do you think? What do you have to make sure that the tail of one of the vector has to be same as the head of the other vector. Means first vector's what? The terminal point has to be same as second vector's initial point. Then only you can apply what? The resultant rule for triangle law of addition. Okay. If A and B are two non-collinear vectors having the same initial point, great, let's do it. A is over here, same initial point. So A is, let's say, like this, and let's say B is like this. Now what they're saying, what are the vectors represented by A plus B? So just do one thing, translate this vector B like this over here. So like this over here. Okay. Parallelly, this is going to be what? B. Okay. And then I'm going to do what? The resultant will be what, bacha? We know this from parallelogram law of addition. This, no sir. So what is my resultant? If this is O, this is A, if this is B, what is the resultant for A plus B? A plus B will be what, bacha? Check here, it'll be OB, sir. Yes or no? OB, sir. Okay. What about A minus B? What about A minus B? Please check. For this, I'll draw this diagonal. Okay. Let me call this to be A, B is there, no? I'll call this to be C. Okay. This to be C. Now, how will you represent this? So, please check. So, if you check, this is again, the same rule is applying, tail and head. So, I can write this again like this. OC vector plus CA is equals to OA, triangle law of addition. Correct? This I can get directly from what? I don't have to even draw that. I can get directly from parallelogram rule also. I can just ignore this line AB and get the answer from parallelogram rule. You are not sure? Let me erase this part. Let me erase this thing. Okay? Isn't OA and OB are forming, OA and OC are forming a, what do you call, is forming parallelograms adjacent side? Correct, no? Any angle can be there. So for that reason, what is the resultant of the two sides, A and B? The diagonal, what's the diagonal here? This is a diagonal, no? Diagonal will be this only. So this is my A plus B. So now I can just join this point like this. What is this point? It was B. So my OB is the answer. OB vector is the answer. Okay. Now let's look at the second part. OC. What is OC, bacha? Simply vector B. What is CA? Unknown. Please check. What is OA going to be? OA going to be vector A. Bring B on that side. It will become CA equals to vector A minus vector B. Isn't that what they were asking? Please check. They were asking A plus B. We got that as A plus B is coming as OB. The diagonal of the parallelogram forming using the adjacent side, which is given as A and B. And what is the other one? The other diagonal of the parallelogram. Okay, C to A. So this is your answer. Very good question. Okay, because what happens, no, there's no information given. You will not have any in conclusion like that. But basically this is the conceptual problem. So if you draw the situation and analyze from there, the diagonals are representing A plus B and A minus B. The whole situation is about what? To understand the diagonals of a parallelogram given the sides with, adjacent side are A and B. Okay, chaliye. Moving on to question number 3. Before that, properties. We'll have to talk about one more concept. Properties, sir. Please have a look. First property. Vector addition is commutative, isn't it? Please check. If I write OA plus AC for this triangle, I'm saying, I'm going to use both the triangles over here. Parallelogram is drawn like this. This is O, this is A, this is again A, okay, this is vector B, this is a line like that, okay, C, vector C, let me just highlight it once, vector A, B, B, and like this. So if I see which triangle, please have a look. Triangle OAC. Triangle OAC. What I'm doing, I'm adding A plus B. I can do that, right? Please check. This is the head, right? So I don't have to even write that. Let's check here. OA plus AC. Check here. Terminal point of the first vector is same as initial point of the second vector. What is the answer? OC. Yes or no? What is OA? So simply A. What is AC? So simply B. How much is AC? Says A. A plus B is coming as C. Now if I take this triangle, please check. Same condition is applied over here also. Is it not? Please check. If I for the triangle, I'm taking the other triangle now. Which triangle is this? OBC. Triangle OBC. For this triangle, please check. I can write what? Vector OB plus PC vector BC, okay, is equal to what? Is equals to OC. How come, sir? Terminal vector over here, terminal point over here is B, initial point over here is again B. So please is common. Answer is what? OC again. Yes. What is OB? Please check. OB is B. And what is BC? BC is A. BC is A. B plus A is how much? B plus A, OC. OC is what, sir? OC is again C. So whether you add A plus B, you're going to get C. Whether you're going to add B plus, you're going to get C. So basically, what is it? Basically, the result is whether you add A plus B or B plus A, you will have the same answer. No. This is the property of commutative addition. Addition property of, commutative property of addition. Correct? A plus B or B plus A is same. Alright, same thing is written over here. Have a look. Okay, I gave this in the slide because if you are not able to read from my handwriting for some reason, you can have this concept from the PPT also. So this is very important to have this PPT to have the concepts at one place, because how many places you will look for the concepts. If you're watching video over here, you're learning from me, you should have the notes all at the same time. How you get the notes? I hope you've joined the WhatsApp channel by now. If you have not joined, please join the WhatsApp channel and get all the class notes every session in the WhatsApp directly. Okay, chaliye, this is it. First property is defined. Simple property. Shall I move on to the next one? Yes. Vector addition is associative. Means whether I add A to B first or B to, or then to C, or add B to C first and then to A, result will be same. Let me show you by drawing a figure. So let's say this is my vector A, okay, and this is my vector, let's say B, vector B, okay, vector A, vector B, and I have this as my vector C. What is this? Vector C. A, B, C is written like this. Now if you add, the first condition I'm taking right now, the condition number 1, if I add A and B first, and then I add this 2 with C. So if you add A and B first, what's the resultant, bacha? Please tell me. Please understand this. Very important. This is a resultant. Triangle law of addition. What is this? A plus B, sir. This is A plus B, sir. Now to add A plus B with C, what you have to do? You have to join this line, sir. You have to join which line? This line, sir. What is this going to be? A plus B plus C. Yes. First A to B, triangle of addition. Again, this vector plus this vector. Again, triangle of addition, right? So I can write it as A plus B plus C. Alright. Now next one. From this I am reaching the same point. Please check. If I write the edges also, O, A, B, C. So what's the answer? Sir, again OC. OC is the answer. Now if I write first B plus C, let's say, I'm going to take a case where I'm doing what? A outside, I'm going to add B plus C first. Please check. So if I add B plus C first, the triangle will be over here, B plus C. This is the triangle, B plus C. What's the result for this white line? It will be bacha B plus C. Can you see that? It's going to be B plus C. Okay. Now B plus C I have for these two sides, for these two vectors. Now add A to this. Add A to this. So again you'll have a triangle. This one OAC. A plus B plus C will be what? Please check. First B plus C gives you the line AC. B plus C gives you the line AC. And what is that? You're adding OA again. You're adding what? OA again. OA plus AC is how much? Sir, OC again. Please check now. Terminal and initial point are same. So OC again. OA plus AC is what? OC again. So whether you go A plus B plus C or A plus B plus C is same thing. Sir, you are saying the same thing over and over again. Is it? Please check. Whether you add these two first and then with C, or you add the other two first and then with A, the result is same, which is how much? OC. This is what? Associative property of addition. Okay, simple. Same thing is written over here also. I've explained you with the figure. Simple enough. I hope you understood this, right? Please have a look. Please revise through the things. Actually, one more thing. Very simple concept, but please revise all the slides after the session. Okay, go ahead, download the notes and revise all the sessions, all the slides of the session. It's important, short video, no? So concept is not very difficult or tricky to solve, but if you don't understand it, you will keep forgetting it. You will not get answers or you will not get questions on this chapter. So please make sure you revise these things very sincerely. Okay, it's because there's no formula approach, it's completely purely conceptual, so you'll have to be very sincere in the revision. Okay, third property, existence of additive inverse. Yes, please check. if you add what, a to 0, what is the answer? A to 0 answer addition, sir, is a only, no? I'll show you. Please check. A to 0 vector. I can write a vector, let's say, as what I have taken here already, OA. Can I write the vector a as OA? I can draw it also. OA. This is my vector A. No problem whatsoever. What about vector 0? Vector 0 is a vector which has same initial and terminal point. So if it is, let's say, A, this also is A. Correct, na? The vector which has same initial and final point is what? Vector is a 0 vector. So I can write this as what? Vector AA. Now add this. Please add this. OA plus AA is how much? Again OA only. And what is OA? OA is A. So what is it? If you add 0 to a vector A, you're going to get result as A only. So again, since you know this, A plus B is same as B plus A. So A plus B, either you add 0 plus A or A plus 0, the answer will be what, bacha? A only. Simple enough. Simple enough. Existence of additive inverse. Valid. Please check. It means if you add vector A with negative of vector A, what is that? Answer is 0, sir. I'll show you. Let's say vector A is OA, no? So add OA. Negative of A means what? I have to reverse the points. So plus, what is it? AO, no, bacha? OA plus AO is how much? Sir, it's OO. OO means what? Same initial and final point. Same initial and terminal point. What is the answer? 0 only, no? Please understand this. A minus A. Minus A is what? The negative of the same vector. If you add them, the result is 0. How come, sir? A, if I take it as OA from here, what is negative of A? From this side, negative of A will be written like this, na bacha? This is my negative of A, right? Okay. I'll have A over here and O over here. So the point which A was in terminal over here, it becomes initial, and point O was initial over here becomes terminal. So I wrote it as AO. Please check same A and A. So I can just take O and O. What is the answer? O. O is what? Whenever you have same initial and final point, it will become what? 0. So basically, you started from here, reached here, and you started from here and reached back. So it's the same point. It means what? 0. It means what? 0. Please excuse me. Okay. So I hope this is okay for both additive inverse and additive identity. Correct? Chali. Moving on to the vector polygon, sir. Vector polygon is very simple, bacha. Let's say I'm writing, I can draw any number of vectors. So let's say vector A is like this. Vector B is like this. Vector C is like this. Vector D is like this. Vector E is like this. Vector F is like this. Then you are looking to find what? Sum of all of it. A plus B plus C plus D plus E plus F. All these vectors. What's the answer? Simply AF. This point. The last one will be the resulting vector. This will be your resulting vector R, and it will have a opposite sign of or inverse of the sign of other vectors. So this will become what? Vector R will be what? This is vector R, no? So please check the direction. It's very important to know this. This is the direction over here is ulta. See, a cyclic order is there. Cyclic order is there. But for this one, this is the resulting vector. What is it? This vector is a resulting vector. Resulting vector. So for this, what will happen? It will be having opposite sign. It will have an opposite direction or inverse direction. Please check. This is okay. Same thing is written over here also. Alright. Now this completes our property side. Okay. Now I'll move to what? Questions now. Okay. So I hope you had fun learning the properties of vectors. Simple problems were there, and simple situations were there. I try to explain you with the figures. If you have any other doubts, please let me know. I'll try to include your doubt solution in the coming sessions, or I'll try to help you in the comment section only. So any doubt that you're having, bacha, please let me know. Please let me know your queries, anything that you want to ask me in the comment section of the video. Okay. And I keep requesting one thing. Please join WhatsApp channel, because if you're watching the video that you are, then please get benefited from the video, solve the questions, have the class notes at the same time, right? Okay, find the sum of vectors A given as I minus 2j plus 3k. So sum of all the three vectors, no, they've given three vectors here. Please check sum of all the three vectors right here. Vector A is what? I cap minus 2j cap plus k cap. Okay, what is vector B? Minus 2i cap 4j cap plus 5k cap. Okay, and vector C is I cap minus 6 j cap minus 7 k cap, right? In direction of x, y and z, add for I cap together. This is what, bacha? 1 plus 1, positive minus 2, so 0 I cap, right? Now this is plus I, so plus 2i minus 2i is 0 I cap. Now 4 here, what does it tell me here? Plus 4 and minus 8, right? Minus 6 minus 2 is minus 8 plus 4, so it's going to be what? Minus 4 j cap and plus 5 plus 1 is 6 minus 1 is minus k cap. What is my final answer? Resultant of A plus B plus C is given as what, bacha? Minus 4 j cap minus k cap. Please check the answer. Okay, please comment your answer for question number 3 if it is different. Okay, if D is the midpoint of side BC of triangle ABC, then prove that AB plus AC equals to twice of AD. Okay, so how will I prove it? First, let's draw the triangle. A, B, C. How much is this? This is D. D is the midpoint, right? D is the midpoint. Okay, AB. So AB will look like this. AC will be this. BD, I can write it like that. Okay, triangle rule will apply here also, and this is my resultant. Now look at triangle ABD. Please check. Triangle ABD. Triangle law of addition will say, give me what, bacha? AB plus BD equals what? AD. Correct? Please check here. Terminal point, initial point for AB and BD. Correct? No? So AD. First equation is this. Same way I can write what? Triangle ACD. Triangle ACD. I can apply triangle rule again. For that, AC plus CD. Please check here. AC plus CD equals to what? Again AD, bacha. Now add equation 1 and 2. 1 plus 2 if you do, what are you gonna get? AB plus, I'll write AC. What is the other one? BD plus CD. Okay, equals to twice of AD. Now see here carefully. BD and CD are in equal length and opposite sign. BD and CD, because D is the midpoint, so equal length and opposite sign means I can cancel them. So why I can cancel them? Because bacha BD is equals to what? Negative of CD, no? Right, so I can write here minus CD and they'll cancel each other. BD and CD are equal length, equal vectors but opposite sign. Okay, chaliye. So if I write it like this, what's my answer? Final answer is AB plus AC equals to twice of AD. Have a look. Proved, right? Yes, this is the proof of your question number 4. Simple problem. Just draw the figure, apply the triangle law of addition for both the triangles. I've written the name of the triangle also and get the result from there. Okay, moving on. Question number 5. ABCD is a rhombus whose diagonals intersect at point E. Rest we'll see later. First draw the rhombus. Okay, looks parallelogram, but please accept it. It's a rhombus only. Join the diagonals because they're talking about diagonals only, right? Yeah. So A, B, C, D intersect at point E. So this is my point E, bacha. All right. What else they're saying? They're saying EA, this vector EA plus EB plus EB. EB is this vector, okay, in this way, and EC, again this vector in the opposite direction, and ED, sum of this. So EA plus EB plus EC plus ED equals to how much? Okay, do one thing, club EA and EC together. Club EA and what? Plus EC together, and then club EB and ED together. Okay, now understand this, AE and EC length are equal, no? Because diagonals bisect each other for the rhombus. It means AE length or EA length is equal to what? CE length, or what do you call EC length? Length are equal. What about the vectors? EA is equals to negative of EC, opposite sign. So EA and EC, if you want I can write it like this. I'll write EA as it is, okay, and I'll move this, okay, or maybe I can just change this side. I'll change EA only. I can write EA as what? Negative of EC, right? Plus EC. Same way, EB as it is, and negative of what? EB for ED. ED and B again the same thing. ED is what? Negative of EB. Opposite direction, same length. Okay. So what will happen, bacha? Please have a look. Cancels, cancel. What is the answer? 0. What is the answer? 0 vector. Yes, option number A is the correct answer, sir. Yes, option number A is the correct answer. Okay, question number 5, simple problem, just diagonals. One thing you have to remember, diagonals bisect each other and the lengths are in, so lengths are equal, and the direction of the vectors are given EA, right? So opposite direction to the other one, EB or EC and ED. Combine them with the same diagonal and get the result. Question number 6, the vectors 3i plus 5j plus 2k and 2i minus 3j minus 5k, 5i plus 2j minus 3k form sides of what? Okay, so triangle is given, right? For it to form triangle means what? It has to satisfy this condition, right? Doesn't look like a triangle. Let me make it look like a triangle. Better, right? Better, no? So write the sides length also. What is it? 3. 1 second, sir. 3i cap plus 5j cap. 3i cap plus 5j cap plus 2k cap. And what is this? 2i cap minus 3j cap minus 5k cap. Okay. And the sum should be equal to what? The last one. Please check. 3 plus 2 is 5. So correct. 5i cap is satisfying. 5 minus 3. So 2. Correct. 2j cap. And 2 minus 5. So minus 3k cap. It means if I write these vectors to be, vector A, vector B and vector C. Okay, vector A, vector B and vector C. Then I'm getting vector A plus vector B equals to vector C, right? You can see in the triangle law of addition over here, sir, like this. I'm getting the result like this. It means it forms a triangle. But which type of triangle? For that I have to find the side length. How can I do that? Please check. Okay, so I can do it like this. Please check. The 3 square is how much? 9. 5 square is how much? 25 plus 4. 9 plus 25 plus 4. Okay, length of the vector. How much is that? 13. 5 plus 4 is 9. So 8, 3, 38. First one is done. Okay, second one, please check here. 5, so 25 plus 9 plus 4 again. Okay, for the second one. Okay, this also, this is root 38. This also is, please check. 4 plus 9, 13, 13 plus 25, root 38 again. What about this? Please check. 5 square, 25 plus 2 square, 4. So 29 plus 9, again 38. So all sides are equal. Okay, in this case, option number D is correct. Option number D is correct. Okay, root 38. Equilateral triangle. Triangle we proved. Sides are equal means equilateral triangle. Moving on from question number 6 to question number 7. ABCDEF is a regular hexagon. Regular hexagon means all sides equal. Okay, please draw it. Let's draw this bacha. Looks okay. Sides names are what? Side names are A, B, C, D, E and F. Okay. They are saying AD. They are saying what? Excuse me, AD. So join AD. Diagonal like this. EB, E to B. So this is EB, okay, and FC like this. FC is equals to how much? Now please have a look. If you remember the properties that you have learned for hexagon, AD will be twice of BC, right? If you have a doubt, I can give you a hint from grade 10 also. Please check. If you produce this thing, it'll form a triangle, right? These two are parallel lines, no? It means what? Parallel lines means what? It'll be half of it, so twice of it, okay? We don't need that reference, just understand this, because since it is a regular hexagon, sir, AD is twice of BC, okay? Next, what is it? EB, right? Next is EB is twice of what? FA, twice of FA, all right? And same way, what is it? Next is what? EB is there, then FC. So FC is what? FC is twice of AB. Please check. Twice of AB. Can you see it from here? Twice of FA. Not visible that much. I'll write clearer. Okay. 1 second. Twice of FA. Now clearer? Okay, better. Okay, if not clearer, it's better. Chaliye. Now add all the three. What are you gonna get? You're gonna get AD plus EB plus, what are they asking? FC, right? Is equals to what? Twice of BC plus FA plus what? AB. Okay, now very important. BC plus FA plus AB. I can write BC plus FA plus AB like this. Please check. BC plus FA plus AB. The property that we have learned, I can arrange in any fashion. So write FA first. Write FA first and then write what? AB next. And write what next? BC. Please check. BC. Okay. FA, AB and BC. Okay. What is it, bacha? Please tell me. FA, AB and BC. FA, AB and BC. Vector polygon is forming, right? FA, AB, BC. FC is the answer, sir. FC is the answer, sir. Okay. Please check here. A and A, terminal and initial. B and B, terminal and initial. So FC. So write this whole thing as 2 times of vector FC. And what is vector FC? Vector FC is twice of AB. Right? Vector FC is twice of AB. So replace that. Twice of AB. What is the final answer? 4 times of AB. Whatever they were giving us to find, we got that answer to be 4 times of AB. So option number D. So question number 7 is done. Please have a look. Please have a look. Simple problem. Very, very simple question. Just you have to know the concept of vector algebra and some properties of regular hexagon vector polygon and some properties of regular hexagon. Okay. Chaliye. Question number 8. A person goes 2 kilometers east. Okay. So let's say he is here. From here he goes what? 2 kilometers east, bacha. Okay. If this is, let's say, point origin. Okay, this is my point origin. 2 kilometers east he went. Then he went 4 kilometers west. Sorry, no, 3 kilometers north. So 3 kilometers north like this, let's say. 3 kilometers north means up, right? Then what he goes? 4 kilometers west. This is, let's say, 4 kilometers west. He went over this side. Okay. This is 4 kilometers. He traveled this way, this way. Now from there he goes 1 kilometer north again. 1 kilometer north again. Let's name these points. So this is O, this is A, this is B, this is C, and now final point is D. What's the D point's coordinate? Please tell me. D point's coordinate. If this is origin, he has moved how much left? This is 2 and he moved total 4 left. from the extreme 2. It means this point has to be what? Having D point's coordinate is what? -2, right? This side is +2. He went 4 negative. So 2 minus 4 is how much? -2. How much is he went up? So 3 and then 1 more. So total 4. The point's D coordinate is what? -2, 4. Okay. So you have to write the position vector of this. How will I write it? So it will become what? It will become, okay, and this point is taken as vector A. They have given this as vector A. This as vector A. Okay. Chaliye. So vector A is going to be what? -2i cap plus 4j cap. Yes. Okay. Now they are saying over here, please have a look. They are saying that 3a cap plus 5b, another vector b, okay, is equals to what? 9, 32, the coordinate. So basically what is it? 9i cap, I can write it like this. Excuse me. 9i cap plus 32j cap, right? So we have to find what? The vector b we have to find out, right? Find the vector b, okay? So please check. I can take this on the other side. What I'll have? 5b is equals to what? 9i cap plus 32j cap minus 3a, right? So 9i cap plus 32j cap minus 3 times. So what is a? A is over here written. Please check. Minus 2i cap plus 4j cap. Yes. Have a look. So I'll write this 9i cap over here and -3 into -2, so +6 i cap again. Next is what? 32j cap. So 32j cap. Please check. -3 into +4, so -12 j cap again. Okay. This is j cap, bacha. Okay. This is what? 5b vector. I want to find what? I want to find vector b. So vector b will be, one second. Vector b. So vector b will be given by what? Please have a look. 9 plus 6, 15i cap plus 32 minus 12, 20j cap by 5. Because 5 I can take on the other side. So I get vector b equals to simply what? 3i cap. 20 by 5 is how much? 4j cap. Right? If you write in the form of coordinate means vector b will be equal to what? Please check. 3, 4. My final answer is what, bacha? 3, 4. Option number is D, sir. A very good question. Calculative little bit, but not that difficult to tackle. Understand this from the point of coordinate axis. Okay, I can take x as I cap. There's no third dimension over here. There's no k cap. Only I cap and j cap is there. So I hope you understood this. Yes, the final answer is 3, 4. Shall I move on? Yes. Question number 9. If ABCDE is a pentagon, then resultant of AB, AE, BC, DC, ED and AC. Chaliye, let's draw pentagon first. Pentagon, right? Pentagon. So I can draw the pentagon like this. Okay. A, B, C, D, E. Alright. What are they saying? They're saying AB. One second, bacha. They're saying vector AB, a resultant, right? So plus. So vector AE plus vector BC plus vector DC plus vector ED plus AC. Please count 1, 2, 3, 4, 5 and 6. So 1, 2, 3, 4, 5 and 6. So AB, AE is over here. Okay. BC is over here. Okay. DC is like this. ED is like this and AC is like this. So full mess if you see the direction sense in the figure. So we don't have to use the figure in this case actually. So lucky for us, please have a look. We have to use what? The concept of triangle law, or what is the main thing? The terminal point of the first vector has to be equal to the initial point of the second vector. So I'll arrange something. I'll club them together. Please check. Look for that combination. AB, BC. Okay. AB, BC. All right. AE with ED with CD or DC. Correct? Let's see the combination now. So I can write this as AB plus BC together. Okay. Plus AE plus ED plus DC together. The last one, the left out one, simply AC. Please cross check. AB plus BC is AC. A plus ED. A plus ED is what, bacha? AD. Write it like this. And DC over here. This is simply AC, right? Please club this AC and this AC together. So 2AC. AD plus DC is what again? AC. Club them together. What is the answer? 3AC. 3 vector AC. Option number B. Option number B. Please have a look. I hope this is visible. Yes. Okay. All right. So we don't have to consider the figure here. I just wanted to show you how will it look like. So basically we can apply the triangle rule, no? So that's why it is. Okay. All right. So if you want, you can see from here also. Please check. AB plus BC is AC, right? And same here. A plus ED plus DC equals to AC, right? Cannot see that? Please check. AB plus BC. Which rule? Triangle law of addition. What about AE plus ED plus DC? Vector polygon, and AC is AC only. So from the first one, triangle law, you're getting one AC. From the vector polygon, you're getting the another AC, and the one AC is already there. So 3 AC. If you want to use the figure, you can use it like that, or you can use this simple algebraic approach also. Yes, AB plus BC, triangle law. AE plus ED plus DC, which one? The vector polygon, and AC is AC. So we have 3 cases of AC, so 3 AC. Moving on to question number 10. ABCDE is a regular hexagon, and AB, AC, AD, AE, AF equals to n times of AD. Hexagon. Let's draw the hexagon, bacha. Okay. AB, CD, EF. Okay. Now they're looking for which side? Let me draw the sides also. So AB is here like that, AC is here, AC means something like this. Okay, AD, okay, AD is also there, so like this. Next what? A is also there, so like this. Next what? AF, like this. Okay, let's see. What can I do about it? First write the sides. AB plus, I'm only going to take what? LHS, bacha. Okay, only LHS I'm considering. AB, AC, AD plus AE. Okay, and what is it? Plus AF. Plus AF. Now AB can be written as what? This is parallel, right? So ED, right here instead of AB, write what? Please see this. AB, I'm writing it as what? ED. Now write AC as it is and AD as it is, and keep AE also as it is. AE also as it is. What about AF? AF is same as CD. Write this AF as vector CD. Please check now. Please check now. I can combine what and what? AE with ED, AC with CD. How come, sir? We are looking for what? We are looking for n times of AD, right? On the RHS side. So club them together. ED with AE, right? So AE plus ED, first one. AC plus CD, second one. AC plus CD. And the last one is already AD. No problem. Have a look. AE plus ED, same E and E. So what is the answer? AD, sir. Over here, C and C. What's the answer? Again AD, sir. And the last one is already AD. What I get the answer for all of this? 3 times of AD, sir. 3 times of AD. So if you compare this result, 3 times, so what I'm getting LHS equals to what? 3 times of AD is equal to what? RHS, right? How much is it? N times of AD, 1 second, equals to what? N times of AD, compare this, N equals to 3. N equals to 3. So option number C. AD plus AD plus AD, 3AD, no? Compare it with the RHS, you're gonna get NAD. So N equals to 3. Simple. Got it, sir? Yes. Simple problem. Very simple. You have to just understand how to make use of the figure. Okay. Chali. So moving on to question number 11. Okay. Question number 11 says 3 non-zero non-collinear vectors A, B, C are such that A plus 3B, okay, is collinear with C. Great. Great. Is missing over here? Is collinear with C means? Please check. So what it means, the collinear property, if you remember this, A plus 3B equals to what? I can write lambda times of the vector C. My equation 1, bacha. That's what it means, right? A plus 3B is collinear with C means A plus 3B equals to lambda times of C. While 3B plus 2C, 3B plus 2C vector is collinear with A. So right here mu times of A, lambda and mu are my constants. Okay. Now what are they asking? A plus 3B plus 2C equals to what? A plus 3B plus 2C equals to how much? So please check. A plus 3B value I can see from here. If I use what? From equation 1, from 1 I can write A plus 3B as lambda C. I can write this as, please check, 1 second. I can write this as A plus 3B plus 2C plus 2C equals to what? A plus 3B will become what? Lambda times C, okay, plus C, okay, plus 2C, okay. Now take vector C common, I get what? Vector C, so will become lambda plus 2 times of C. Let's call this to be equation number 3. Now in this A plus 3B plus 2C, I'm going to use equation number 2. I'm going to use equation number 2. So from 2 I will write, from 2. Okay. So check here. A plus 3B plus 2C equals to, A will remain as it is and 3B plus 2C will become what? It will become mu A. Mu times of A. Take A common, 1 plus mu. Equation number 4. Equation number 4. Now if you compare, you can see from equation 1 and 3 and 4, equation 3 and 4, what are you getting? Equation 3 and 4, LHS is same, right? In both the equations, this LHS is same, right? Correct? So RHS also has to be same. What I'm getting? Lambda plus 2 times of C equals to what? 1 plus mu times of what? Of A. Is there a vector A on this side? No, right? It means what, bacha? It means 1 plus lambda mu has to be what? 0. Because there's no A on this side. How will you compare the coefficients? So 1 plus mu 0 means what? Mu is what? Mu is simply minus 1. Same way you can do what? Lambda plus 2 is also equal to 0. So what's lambda? Lambda equals to minus 2. Okay. Now if you put this in any of the cases, whether you put over here also, lambda equals to minus 2, put here. Minus 2C plus 2C, how much is that? 0. Let's say I'm going to use the equation number 3 only. So I can say from equation number 3, please check. Equation number 3, what is the equation number 3, sir? A plus 3B plus 2C is how much? Tell me. Lambda plus 2 times of C. Lambda is how much? Minus 2. So minus 2 plus 2 times of C means what? 0 times of C means what? Simply 0. So the given value that they were looking for, a plus 3b plus 2c, a plus 3b plus 2c, have a look. This one is equal to what? Is equal to 0. Answer is what? D. Answer is D, sir. Yes, please have a look. Yes, a very good question. I'll show you the flow once more. Okay, so first we got the relations for the collinear functions. So collinear vectors that they've given, okay, collinear with these like this. So I've taken a constant lambda. Please see the definition that I explained you in the previous session for the collinear vectors. Lambda and mu I took for the constant. Okay, then I used it in the expression that they were asking, vector a plus vector 3b plus vector 2c, and then I got result to be what? Comparing, I got two equations, equation 3 and equation 4, compared them to get what? Mu as minus 1 and lambda as minus 2. I used the equation 3 and put lambda is minus 2. I got the result to be, this thing to be equal to what? 0. Okay, simple enough. This question is done. Moving on to question number 12. Question number 12. Okay, the last question of the day. Okay, so I hope you liked so many questions that we have solved, and I hope you were able to answer all the questions with me. If you need to download the notes, please download and join the download and join from what you call WhatsApp channel. Join WhatsApp channel and download all your notes from there and solve all the questions. Okay, great. If a vector a equals to I plus j minus 2k, and b equals to 2i minus j plus 2k, and c equals to 3i minus k, okay, and c is given as m of a plus n of b, then m of n, m plus n equals to how much? Oh, very good question. Okay, let's see. I'll write in this form. So c equals to what? M of vector a plus n times of vector b. Write it here. I'll need more space. I'll need more space, sir. Okay, please check. What is c? C going to be what? 3i cap minus k cap. Okay, now be careful in while writing this, because you might make a mistake in taking coefficient or taking sign. So be very careful with that. M times a, what is a? I plus j minus 2. I plus j minus 2k for a, right? This is k, bacha. Okay, now for nb, so plus n times of b is going to be what? 2i minus j plus 2. 2i minus j plus 2k cap. Okay, now I'll compare the coefficient of what? I, j and k on both sides. So for I, I'm going to get what? Please check. For I will get m over here and 2i over there. So 2n over there. So m plus 2n for I cap. M over here, 2n over this side. Now I'm going to do for j cap. What is it, bacha? Tell me. M over here and minus n over there. M minus n. Okay. Now for k cap. Plus for k cap. For k cap, I'll have minus 2m on this side, minus 2m over this side. Please check. Minus 2m. Okay, minus 2m. All right. Not visible. That looks very messy. So it's 2k cap. Minus 2k cap. Okay. Minus 2k cap. So minus 2m over there, and for this I get plus 2n. Okay. Chali. Now I will compare what? I will compare the coefficients of I and j. For I, check here, and for j, nothing is there. It means 0. So first check for j. So for j, compare what? Coefficient of what? J cap. So this side I have 0. 0 equals to what? M minus n. It means m equals to n, sir. M equals to n, sir. Now what? Compare for I cap. Compare coefficient of I cap. What I get here on this left hand side? Simply 3. Simply 3. And on this side, please check. M plus 2n. M plus 2n. I can write this as simply m plus 2m only. Answer is 3m. I can cancel 3 and 3, right? Cancel 3 and 3, right? What I get? M equals to 1. Yes, m equals to 1. Now have a look. If m is 1, what is n? m equals to n equals to 1. What are they asking? M plus n. So 1 plus 1, how much is that? 2, sir. It is 2, sir. Okay, I have two options here. One of them has to be minus 2. So let me take this to be minus 2 here. Okay, option B is correct, bacha. Please check. Option B is correct. This has to be, this is minus 2. Okay, please have a look. This is minus 2. I think typing mistake. Please forgive me. Answer is 2. Option number B. Please have a look. Okay, I compared the coefficient of I cap and j cap. By doing what? By using the statement that they gave, C vector equals to m times of vector A plus n times of vector B, where A and B was also given in the problem. Yes, so this completes this particular session, bacha. Okay, I hope you found this helpful. Okay, so I want to know whether you're practicing or not. Please, any queries, any questions that you have, ask me. I want to do better and better. Please work harder and harder. Okay, and I'll see you in the next session. Okay, this is it for today. Take care. Bye bye.